in early 2022 when we wanted to onboard more women and diverse people into the ecosystem. So we did two series of Solidity boot camps back in 2022, from where we got a lot of really good graduates. You see a lot of amazing DevRels on Twitter. Many of them graduated from our first Solidity cohort. And we have been since then we have been doing a lot of educational initiatives, but the Phoenix Guild has grown bigger, and we are focusing a lot on education just internationally. And so this year, just a couple of months before, I picked up so the Phoenix Guild has a lot of different chapters across the globe. For example, we have TPG, the Phoenix Guild Chennai, which is a city in India. We have TPG Kenya, we have TPG USA. So, like that, we have a lot of different chapters. And each of these chapters are setting up their own mission and vision, mostly onboarding people in Web3 via education. So, earlier this year, just a few months back, I started a new chapter, which is again bringing back the initial mission and vision that we started with, which is diversity. So, it's called TPG Women. I'll share the Twitter link with you in case any of you are interested in following. But this study group we wanted to start as an initiative under the TPG Women umbrella. And one of the main motivations for this is of course to onboard more women into the Web3 and the Ethereum space. And we wanted to keep this study group a little small. It is close-knit, and keep it women only. So you find it as a safe space for you to ask questions, interact with your hosts, and study a bit more closely. And that's why we have a Telegram group as well, where you can put your questions. Apart from the Phoenix Guild, I work full time with the Starknet Foundation. Starknet is a layer 2, and I work in the ecosystem team as a DevRel. And I've been with the ecosystem for about 1.5 years now. I've worked with other different protocols, building educational material and such. And I also run two other study groups. One is called Women in Ethereum Protocol, but it's a hands-on study group. It's not a study group, but it's to encourage more women to actually contribute to the Ethereum protocol. And the other study group that I run on Wednesdays is called Women of Starknet, where we study Starknet smart contracts together. That's why I have Reeth and Fabiola, who are the actual hosts for this study group. And they will be taking you through the conceptual properties of Ethereum. So this is going to be an actual study group where you're actually going to study, you're going to come together, ask questions and all of that. And the hosts have prepared, every session for you in a way that they will be covering certain topics. So let me share the screen with you as to what would we be covering as part of this study group. So Ethereum has a fellowship program called Ethereum Protocol Fellowship. And my aim is eventually to hope that after the study group, maybe if you're able to get into the fellowship program, that would be a good plus for everyone. And this fellowship program is called EPF, and they have created a study material. I hope my screen is visible. Yeah,
Yes,
it's
yes,
okay.
yes.
So this EPF, that is Ethereum Protocol Fellowship, has created this study group, which has materials for several weeks. So, for example, week 1, which is an introduction to the protocol, week 2, which is the execution layer, week 3, which is the consensus layer. We are going to be following, sorry, we are going to be following this wiki. I mean, these topics, but there might be some slight changes that the hosts have made to these topics so that it is much easier for you to grasp and that you're able to finish in a period of 6 to 7 weeks. And all of this study group material is also available online. So whatever the hosts have prepared, right? It may not be that they are covering all the points. What they're trying to do is in the 1 hour that you have to study, they have picked up the most important points and they are going to cover that. And please be mindful that both Reeth and Fabiola are also not, and none of us for that matter, even people who work in Ethereum today, may not be experts in all the topics in the Ethereum space. So if there are topics that, let's say, you are not very clear on and there is a confusion, don't hesitate to like just Google it, understand what it means, maybe watch some supplementary videos for that. If you found something good, then share it with your study group mates, etc. Right? So this is going to be, that's why this is a closed study group, which is a women only study group. This should be a place where the hosts feel comfortable to also share the knowledge they have, but you should also feel comfortable to ask questions. Don't feel like, oh, like I don't know about this, is it a valid place to ask? Let's say if we don't have the answer, we'll try to get you the answer and connect you with someone who can give you the answer. So this is the material that we will be following, and all of this also has slides and recording that you could watch just independently of the study group. My suggestion would be that if you have the time, at the least just read the topics. There is a pre-reading with all of the weeks, right? At the least try to complete the pre-reading, because this will give you a lot of context in terms of what is happening. Why have they chosen this topic, and why what are the subjects that are covered in this topic. So this is what we will be doing during our study groups. So study groups will be 1 hour sessions taken in combination by Reeth and Fabiola over the next 5 to 6 weeks, and they will be covering different topics that will be part of this. Now, what should you do? What do you do progressively? I haven't discussed this with Reeth and Fabiola, but I got this idea from another study group that was run. And what you can do progressively throughout the study group is explore this concept of EIPs, right? EIPs are Ethereum improvement proposals. Now, as you keep studying about the Ethereum architecture, you will have some understanding of why certain Ethereum improvement proposals were proposed. As the name suggests, Ethereum improvement proposals are proposals or ideas that will improve the way Ethereum works. You're going to study how Ethereum works. So, in parallelly, if you can study the different types of EIPs, you can pick and choose an EIP, maybe to start with, right? And start looking into it. And at the end of the study group, on the final, after your study group gets over, we will have one session where each of you will present an EIP that you have researched. So this is like your, final kind of presentation from the study group. What did you learn from it? And you can pick any EIP in any category. So EIP is under, you have standard track, you have core track, you have networking track, interface track, ERC track, which is Ethereum request for changes, meta track, you have informational track, right? I suggest that after every study group session that you attend, go back and pick one EIP and just study a little bit about it. You can study something old, you can look at something new, but this will help you understand how Ethereum became the way it is right now. Because EIPs are the ones that keep on adding more and more features, right, to the Ethereum protocol. And at the end of your study group, you will present, every individual will present one EIP that they researched on. So it could be a 3 to 5 minute presentation, right? And all of us will learn what is this EIP all about, right? So that's like your potential homework, if you could, and something for you to take out of, right, after this study group. You can publish this EIP as a, something that you understood on as a Twitter thread, right? You can, maybe if you do deeper research on that, you can even submit this as a talk proposal later on, if you research on a newer EIP, right? So this is the main aim, for you to learn about Ethereum and then make sure that you get something out of this entire experience, not just the conceptual functionality of how Ethereum works. So this is the way we have designed the study group. I'll open up for questions right now. If anyone has any questions, I will post the links to the EIP link, this website, as well as the Ethereum Protocol Fellowship. as well. Thanks, Fabiola. Fabiola already posted the links. But if you have any questions, don't hesitate to ask. And let's keep the Telegram as a conversational place for us to ask questions on Ethereum just in general, or anything aligned with Ethereum as well. Like if you have questions on what are layer twos, why are they important, or anything that you think you don't understand, right, from the subject material. And others who have some knowledge who want to contribute, feel free to contribute. We want to keep it very open, very interactive, and very like if you don't understand stuff, you should interrupt the presenter and tell them, hey, I don't understand this. Because we want these study groups, again, why are we having a smaller study group is so that we go at the pace of the slowest person. So that doesn't mean if you ask a lot of questions, you're the slowest person. It means that if you don't understand something, you need to stop the presenter and ask them the questions then and there. Because if you keep building those questions over a period of time, the concepts will become very, very complex. And if your basics, fundamentals are not correct, then you will not be able to attempt the complex concepts, right? So that's the idea. And yeah, I'm hoping that you have a great time with the study group. And if you feel like there are, so right now we are starting straight away with week one, okay? That would mean that Reet is covering some subjects that are associated with week one. Let's say that you didn't understand anything in week one and you find it very overwhelming. Please let us know in Telegram. What I can do is I can take another very basic session for you, which could be something around introduction to Web3, just for few people who are really completely new to the ecosystem. We already shared in the Luma that it will be this particular syllabus that we'll be following. So we are assuming that most people are familiar at least with the basics of Web3. But if you're not, don't hesitate to just ask that, hey, I want a session on this particular topic, or I want a session on this topic. I don't understand it very well. And we will be happy to take a session for you. I also, at some point in time, I will also share the Women in Ethereum Protocol Discord, for which I mentioned that I'm hosting another study group. Every Mondays we host that, where you can also eventually, I think, once you finish the conceptual part, you will be prepared to, if you are into development, you can take up some GitHub issues and you can start contributing over there as well. So that would be a nice progression. And then, of course, start maybe apply for the fellowship next year, and other things like that, hopefully. So, okay, that's pretty much my intro thing. Sorry, it was long, Reet. I don't mean to take your spotlight today. But yeah, over to you, Reet. Reet will be today's host, and we will inform you before the session that who will be the host for the session. It will be someone between Reet and Fabiola. And maybe actually I should open up the floor to for Reet and Fabiola to introduce themselves, and maybe others as well, because we are not that many people in the group. It's good to know each other. Where do you stand? What are your expectations from the study group? Maybe it will be nice to know that. So let's open up the floor to just quickly introduce ourselves.
Hello, hello everyone. Hi Fabiola. Hi, yeah. Haven't seen
Hi.
you all after a long time.
Yeah, that's true. Now we are, even though we stay in the same city. Now you're in Bangalore, you know? Yeah.
Yeah,
Got
yeah.
it.
So I'll just take a quick moment to introduce myself. So as Gyan mentioned, TPG used to host a lot of Solidity cohorts back in the day. So I was actually a graduate of the first cohort, and that's how I started my Web3 journey. And I have been a dev around this space. I come from a computer science background, so it was pretty easier to navigate to the blockchain and stuff like that. But I'm sure as we get ahead, I'll make sure, since I'm taking the first section, I'll make sure that we cover the basics and we get things started in a slower pace. So I've prepared my slides accordingly. I'll leave it up to Fabiola to like introduce herself too.
Thank you. My name is Fabiola from Bolivia, South America. I'm one of your co-hosts for this study group. I'm a software engineer. I've been involved in the blockchain space for 3 years, and I have focused on education, and currently I'm learning Rust. As your co-host, I will help you to guide our discussions, share resources, and ensure we all get the most out of this learning experience. I hope. Yeah, that's all.
Okay, thanks, Fabiola. Maybe anyone else, just feel free to unmute and introduce yourself quickly. Okay, dokes. I see Wes from our Ethereum study group. Maybe Wes, do you
Yeah.
want?
Hi. I'm Vaishnavi. I go by Vaish name. I'm a final year student. My like I have been in this space for the last 2 years, just contributing like participating in hackathons, competitions. Uh, I've started learning Rust and I'm contributing to Foundry and some of the Rust repos. So just started. If anybody wants to like team up with like in any contribution, so just feel free to reach me out.
Woohoo. Okay, I see Diana next on my list. I'm just gonna call out. Why are women so shy to introduce themselves? We have to, I think that is one thing also that we have to overcome in this study group, that we really need to make our voices heard. Okay, come on. I need someone to unmute and introduce themselves.
Hi. Yeah, I'm gonna introduce myself. Hi, so you already called me out. No, I'm just kidding. No, I agree. So I'm Diana, I'm from Ecuador as well. So glad to see Fabiola here from South America. I'm pretty new to the space actually. I've dabbled with NFTs and like buying crypto and that kind of thing, but I don't have much of like a technical understanding of how it works. So I'm pretty excited to learn more and understand like the inner workings and then take that to development. I have a dog, but yeah, that's pretty much it. Thank you. I'm pretty excited.
Thanks, Diana. Okay, who's next on my list? Okay, I see Swarna. Swarna, come on. Come on, gal. Are you able to unmute yourself? Okay, maybe not. Fadi, are you able to unmute yourself and introduce quickly?
Yeah, sure. Hello. Hello. So I'm Fadi. I'm from Belgium. I'm software engineer. So I met Gian at multiple places in Europe. I think 3 or 4 ETC, hackathon, and stuff like this. But I want to learn more from end-to-end project to do end-to-end project on Ethereum. And I know already I did already a lot of things, but I also enjoy to do it around other women and to learn how we can share and contribute to the ecosystem together. Voilà. Nice to see you again, by the way.
Yeah, when you, Fadi. Okay. Lorena says that she's unable to open her mic. No worries. Yeah, Lorena is from Paraguay and she's currently collaborating with Web3 organizations like Seed Latam, which is oriented towards education about Web3 in general. And she does comms for verticals related to nodes and governance. That's pretty cool. You can ask her a lot of questions around that. Very excited to be here. Yay, we are happy to have you. And I think it's a great Ethereum is really a great place to start if you want to deep dive into Web3. Because if you understand a lot of fundamentals here, then you can literally work with any other chain. It becomes very, very easy. So yeah, this is a great place to be. Okay.
Hello, am I audible?
Yes, yes, Anushka, you're audible.
Hi everyone. Sorry. Hi everyone. This is Anushka Bhagolibal from Bhopal, and I am a core team member of TPG Bhopal, and I have even met you, Gyan, when you came here recently. So yeah, first of all, thank you so much for such an amazing idea of taking that women conceptual each session. I am really excited, and I hope this will be an informative session for me, as I'm really into blockchain and I am trying, and I haven't succeeded yet. I am trying. in the development part. So I think I will be able to grasp much knowledge from this. So thank you so much.
Of course. Thanks for being here. It's nice to again see you online. Okay.
Mm.
We have Elizabeth, Mika, and Swarna. Whoever wants to go, just go for it. I say.
So, hi, myself Swarna Deepika, and I'm at my final year of BSc Biotech. So, I'm quite nervous meeting. I would love meeting Web3 women personally. Like, I'm a person who love meeting people, new people. So, I think this session could be informative and I could develop myself and get into Web3, and I used to write blogs on Web3.
Awesome, awesome. Yeah, I mean, as Swarna mentioned, I think a lot of these study groups that we host, where if you are part of any women-only study group, try to also think about going out of your comfort zone and trying to build a brand for yourself, because this is a space where you can get feedback, where you don't feel overwhelmed sharing your experience or overwhelmed asking for tips and tricks. So, yeah, the first step is to really make your voice heard, because Web3 is competitive and it has a lot of opportunities, but also it's competitive in a very weirdish way. Like, you need to really stand out to get good opportunities, be it whether a good developer, whether a good devrel, or whatever role you're in, right? So yeah, I feel like you can use this space to definitely build your persona as you would like to shape it. Yeah, okay. Someone also dropped a message. Oh, Mika, no worries. Yeah, no worries. When you find a quiet space, you can go whenever, not an issue. And Elizabeth, are you able to unmute? If not, then I think we are just right on time. I planned for like a quick 30-minute orientation, and I think we are just on time. Okay, let's get started. Reeth, you are on. And let's go. Oh, sorry, I missed Melody, but was Melody able to unmute herself? Wait, I didn't see.
Yes, I can
Hey,
unmute.
hey, hi,
Uh,
Melody. Yeah, go for it.
Hello, everybody. My name is Melody. I'm based in New York City, and I'd say my background is similar to Diana's, where I have experience more on like the consumer side of using Web3 or interacting with Web3, but not much on the technical side. So excited to jump in and learn and have a supportive environment to do that. Thank you.
Okay, amazing. Welcome, Melody. Okay. Okay. Elizabeth, anytime you want to introduce yourself, even over chat, feel free to drop a message. No stress. Okay. So let's get started for the day. Read you're on. Today I've shared the calendar for 1.5 hours because I know that we could potentially go a bit longer. But anytime you feel like, anytime if anyone feels like it's overwhelming, because it's the first session, and even in general, there's a lot of material that they've covered in this wiki. So definitely feel free to go like, hey, like let's stop, or hey, let's pause, or let's cover this maybe in the next session. So we should go at your pace, and you should feel comfortable learning things that you're at your pace as well. So, okay, Reet, you're pre-recorded, or is this how you look? Oh my God, this is so cool.
I think it's like Zoom has like blurred the background or something.
OMG, this is too good. I have to take a picture. Okay, you start. I will take a screenshot or whatever. I will do whatever.
Yeah, so I think we'll get started. Like, I just want to do a quick overview of what we'll cover today in the session. So we'll start with absolute basics and start with what is Ethereum. Then we'll look at some design principles, followed up with the architectures. So design principle is basically what like we'll cover it in detail. What are EIPs, and I'll also show some resources that you can check out and get started, and then we'll cover the implementation side of things. So in the architecture part, architecture, we'll see that like there are a lot of Ethereums in layer. I'll just explain the architecture, and in the next following lectures, we'll see one by one layers. So Like there's no need to worry about if you don't understand a single thing, because that will be covered in the next class. Same with implementation and testing, we have separate followed up lectures for it. So try, like in this lecture, try to grasp as much as overview of things that you can, so that when we go deeper into each bullet points in the next lecture, you can like basically fill up a picture in your head. And at the last, since like whoever is active in the blockchain ecosystem, there are a lot of L2s and stuff. So at the last, I decided to include a little bit about blockchain trilemma, because that will give you hands-on thinking, like why we need L2s and stuff like that. So I'll right away get started with what is Ethereum. Feel free to like chat in the chat box if I have any questions. So this is an image of like this, I got this image, interesting one, of an elephant, like what people think of different things. So Ethereum also, like different people have sort of different opinions on what Ethereum is. Some people are scared of just the blockchain term itself, and some people think like it is a decentralized computer, which is actually, it is like, it is very easy to understand. If I say that, you know, it is a decentralized computer, the first thing that you think when I say computer, you will see that, oh, like you will imagine a physical monitor sitting right in front of you, but that is not the case with Ethereum. So one of the properties that Ethereum has is obviously it is not physical, and I'm sure we must like understand that. But in simple terms, I would like to explain that Ethereum is a decentralized computer that can execute smart contracts on blockchain, and obviously every blockchain will have its native token. In the case of Ethereum, it is called Ether. So like there are different blockchains, like Ethereum is one of them, and there are others also, like Bitcoin. So I'm sharing a screenshot of the, so like every blockchain will have its own white paper also, but here that you can see is called yellow paper actually. Yellow paper basically will discuss how Ethereum is supposed to be implemented. So if anyone wants to get into that sort of detail, into what exactly Ethereum is, like very basics and very basically in an old teacher format, you can literally read the yellow paper, and I would suggest everyone to go through it, or even just the summary of it to understand what it is. But now let's look at EIPs. Gyan actually showed in the initial lecture, like the website of EIPs. But what are EIPs? So, like, if I'm sitting at India and if you are sitting in a different country, every country will have its own laws. So, who are proposing these laws? Then that is a basically a separate topic. But in India, we have it's, since it is a democratic nation, we have basically people who are proposing that, you know, we need this law, we need we have a constitution and stuff like that. So in the blockchain world also, Ethereum has a large, strong knit of community, and the community people are the people who are proposing these improvement for the blockchain. So that is why it is called Ethereum Improvement Proposal, and it is a gateway, like great way to get started. Even account abstraction and a lot of different advancements, even like Ethereum, like proof of stake and proof of work. We'll see that in a minute, that Ethereum was proof of work before 2022, and during August, I think we shifted to proof of stake from proof of work. So that was also proposed via an EIP. So everything that is done in Ethereum are proposed by the community members, and you can actually go to this website and see what are the proposals being met. Coming to the execution specs. So this is written in Python. So for very easy understandable code, and like for people, like I hate math basically. So for people who don't want a lot of math, this execution specs and consensus specs repo, both the repos are written in Python. So no, again, no hardcore math is required, and you can generate a test based on this. You can test your implementation, whatever you are doing. So you can check these repos out. The links are here, and you can actually try to contribute to it. So that is mostly it. Now, this one is a Ethereum book. It's called Eat to Book. I've shared an link embed to it also in the slides. This is the best way, according to me, to get started with Ethereum and to understand the overview, because it does not only cover the technical aspect for it, but even for people who don't want to get a lot of technical details, this is a great way to start into. And I would suggest, like, definitely go through this one, like right after this session, open this book and take a look at this book. So let's now finally come at the design principles of Ethereum. So I like the first one obviously says simplicity, universality, modularity, non-discrimination, and agility. So this basically means that even though, like, it's like, I think over the past 10 years Ethereum is still being developed, but like people are proposing EIPs, and anyone can actually propose an EIP, one of the community members. But everything that is done on Ethereum and everything that will be done on Ethereum will be done according to this basic design principles. So every EIP should follow and should keep in mind about these design principles. So Linux kernel, if like people have used Linux or have some idea about it, it is a little bit more complex. So that is why it like Ethereum should be simple, and that is why the first design principle is simplicity and universality also. So basically, Ethereum cannot have any features. It is not biased towards any features. Rather than it should be a generalized platform, and it is a core protocol. So Ethereum cannot include behavior features or something of a high level. So for example, there cannot be a token standard implemented on the core protocol itself. ERCs were created on top of Ethereum, not inside the Ethereum. It's not within the protocol itself. Why? Because we need to follow certain design principles. So modularity, let's talk about modularity and encapsulated complexity here. So we have encapsulated different parts of network separately. We'll see that once we go to the architecture part to understand what are the different parts. But to interact with these different parts, we are using very simple APIs, so that we are able to have more security. In case even one of the parts fail, we can interact with the other parts, and that is why modularity comes into picture. So a non-risk aversion also is something, as Ethereum changes, conditioned by what benefit they bring. So if devs are willing to take certain risk for certain benefits, for example, there are three pillars to any blockchain. One of them is security, decentralization, and scalability. So if we want to focus on more decentralization, we might need to compromise a little bit on security or the scalability part. So this is why non-risk aversion comes into place. So devs are willing to take certain risk for certain features, but we cannot compromise majorly on the basic principles. So that is mostly it about the design principles. Now let's look at the architecture of the Ethereum. This is a very deep picture. I have another slide which simplifies it all, but let's start with this one to have a great understanding here.
Reet, sorry to interrupt. Quick question break. Like, I know that there were some few questions around proof of stake, proof of work, and I've tried to answer that. But is there anything that you have that you want me to explain? Like, I can also take another session which will talk about just general stuff like consensus mechanisms and stuff, proof of work, proof of stake, and all of that. But is there anything so far that people want to ask questions on? There were some questions on the chat. Let me see them as well. Okay, so with the proof of work, proof of stake, I will just double down on the things. One is, I think, what is a smart contract? So a smart contract is basically like a piece of code. So if you think about it, the way applications run, right? Right now, for example, you are running Zoom. So Zoom is an application. It is powered by some kind of code. That code has the logic as to how Zoom works. And in general programming, we call it as a program, right? And smart contracts are exactly programs, but they run on the blockchain. So if, for example, you are consumers, right? You bought an NFT. Now, to buy an NFT, there is a logic, right? That if you pay this much, you can buy an NFT, or you can mint X number of NFTs while they're available. All of these are just logics, right? All of these logics are coded onto something called as smart contracts. So it's a piece of code that lives on the blockchain, which controls the logic of the different applications and the different concepts. So I hope that is clear. And we'll not have to go right now too deep into smart contracts, but why is smart contracts important and very associated with Ethereum? Because Ethereum was the first blockchain to allow smart contracts. Until before Ethereum, which was the Bitcoin blockchain, you couldn't really have logic or applications built on top of that. It was just for funds, right? Just you could move Bitcoin around. You could send Bitcoin to one wallet from another, and you could receive Bitcoin. That was pretty much it. There was no logical applications that you could build on top of Bitcoin. And that's why Ethereum is very closely associated with smart contracts, because it was the first blockchain to enable smart contracts, the first blockchain to enable programming, right, on top of blockchain. Okay. Difference between proof of work, proof of stake. I already put it up, but if there are more questions on that, I'm happy to take it. I missed one question between, which is, do AI tools like ChatGPT or the Z editor know enough about blockchain technology to help someone new start building? I wouldn't. I have a bit of a semi-trust issue with AI tools. I think it is interesting. It is good for learning purposes. That is, if you're a beginner and you're exploring something new, I think AI tools like ChatGPT are good. I haven't used the Z editor, so I don't know how good that is. But if you're a beginner and you just want to get started, I think it is a good idea to explore AI tools. But beyond that, if you want to build your own custom logic, then I don't suggest AI tools. So for beginners, yeah, it should be okay. It does have mostly, I think, the new versions 4 and 4.0, 4.0 something has come, I think. They all do have the latest version of Solidity and other programming in blockchain. So yeah, it should help you for sure. Okay. Okay. Diana, you raised your hand if you have a question.
Yeah, I do have a question. Can we go back to the previous slide, please? So I didn't understand what it meant with modularity.
Reet, do you want to take it about modularity?
Yes, sure. So basically, when we talk about modularity, it simply means that there are different modules in Ethereum, and basically those are kept separate, so that we see that Ethereum is we need to follow some universality, so we cannot have features biased towards certain features. Like, it is a generalized platform. When we talk about modularity, it means we encapsulated different parts of networks separately, and all of these parts are connected using simple APIs, so we can interact with those.
Yeah,
But
just to
what does it mean that it cannot have certain features? I don't understand that.
So just to understand how modularity works in the programming world, right? Modularity, if you're building a modular application, what that means is there will be a base layer for that application, and then there'll be a lot of plug and play components, right? For example, think of this as just again the example for Zoom, right? Zoom provides you a base layer where you can just sign up, become a Zoom member or whatever, and you'll get, I think, 30 free minutes or something like that, right? So you get, and then you don't get any, maybe you get some amount of storage. You get few MB of storage or something like that for free. So this is your base application. On top of that, you can buy different packages for different purposes. If you want to add a webinar, that is one plugin. If you want to add a webinar for 100 participants, that is one plugin. If you want to add a meeting which will allow you to meet over 30 minutes, that is one plugin. So this is what in general building modular applications mean. that you keep an application is modular if it allows you to plug and play, and it has different features that you can use at whenever you want to kind of add things. So similar to that, Ethereum as a machine, right? Ethereum as a computer, the way it functions, the way it has been designed is also to have modularity. So, for example, we moved from proof of stake to proof of work to proof of stake, right? So initially, Ethereum used to work in a certain way, and now it started functioning in a different way. That means that component of Ethereum must have been modular, so that there was obviously some effort to switch that, but it was switchable because it was modular. If it would have been tightly built into that computer or into that application, then you can't switch that, or you can't have a plug and play process. So the design principle of Ethereum is that most of the Ethereum components are modular in nature. That is, you can plug and play. You can also use some of the components to potentially build something else. That's why you see a lot of other people are building something which is similar to Ethereum, but not Ethereum. Maybe they are using some components from Ethereum and plugging it into their code, and maybe having some other base component. So that is what like Ethereum's modular design principle means. So if you build anything on Ethereum, then you should have to think that, oh, is it modular enough so that maybe someone else can use it? Or is it modular? Is it a feature which is modular enough that can become like a plug and play?
Okay, yeah, that makes more sense. So you could kind of say it's like customizable in a way.
Yeah. So in the programming world, we call modularity because it is like, it's not just about building custom features, but it's also about building smaller features. Like the
Yeah.
smaller your base feature is, the faster it will function. And so you build something which is modular. So this talks to this talks to this talks to this, like modular services, or from a software engineering perspective, you build an application which is more modular in nature. That is, not everything is kind of put together and made like a one big component. And I think Fabiola also added from a software engineering perspective. Yeah, like a Lego block. Yeah, that's perfect actually.
Okay, thank you. Yeah, that's more clear now. Thank you.
Perfect. Any other questions, or shall we? Okay, let's start with the architecture then.
Yeah, so it might seem a lot of words here, jargons here that we don't understand in this diagram. So I would like to start this architecture with the heart of Ethereum, which is the EVM. So let's just forget that we are talking about Ethereum, and I want to understand, like maybe you must have run codes on Java or some like a similar language to like very basic language of like computer science. So if you know a little bit about Java and how we run codes on Java, we use something called JVM, that is Java Virtual Machine, to run codes on Java. So very similar to it, like it's a decentralized computer engine, EVM, that executes smart contracts on the Ethereum network. So basically, how do we run the code? Like we have written some code, but who will execute that code? Who will run that code on our behalf? Because the data is getting stored on blockchain, right? So that work is done by the EVM here. As you see in this diagram, there are two layers to it, consensus layer and execution layer. So since we are starting with EVM, we will first discuss the execution layer and then the consensus layer. And these both layers are connected back and forth using an API, and the user is interacting to the execution layer. User is not directly interacting to the consensus layer. So just like JVM, we have EVM. It is EVM was created to process the code that we all write in the same way that all machines or computer process the code. It is a virtual environment, and it is EVM is basically the actual execution engine. So for EVM to work, it needs some input, it needs some data. So that data is coming from the state. As you see, like data is coming from the state. So the state is the database that holds all of the addresses, balances, current state, all contracts, and all of the code that we are writing. So Ethereum is basically the whole Ethereum as a blockchain is considered as a global state machine which can return into different states. Why I'm saying it is a global state machine, as at one time the whole of Ethereum will have one state. So EVM will process the output on data, and it will update the state based on some input that the state data will give, which is transactions. So transactions we see.
Sorry, Reet, in this view, you are over the execution layer. Your transactions and something above is being covered by you. I
This
don't know.
one, right? I think, is this better? Or how do I?
Mm, I don't know how to change this view. Wait, let me. I try to do like standard. No, it is not working. Wait, side by side gallery. No. Immersive. I try to do that immersive thing. Actually, let me try that. Maybe it is better. Yeah. Yeah. In this immersive view, we can see the transactions mempool P2P. Okay, state data EVM. Okay, yeah, this is better. Maybe, but before continuing, did everyone understand what Reeth mentioned by what Reeth means by saying Ethereum is a global state machine? Like, do you understand what that means? Can anyone
No,
share what is their understanding? Yeah.
I don't.
Okay, so Diana doesn't. Is there anyone else who understands what that means? What it means that Ethereum is a global state machine?
It basically means the entire state of Ethereum changes at once. Like
Mhm.
if there is a state, the all the nodes will have the same state.
Okay. What does what? Okay, let me go a little bit deeper because we have people who are not from computer science background. What is a state? What is a state? Just for just a generic question. What is the state of an application? What does it mean by and when an application has a state? What do you understand by that?
Is it kind of like a version of something of the app?
It is kind of for an application, it is more or less like if you just freeze this application right now, this Zoom application that is running on my computer right now, the state of this Zoom application is that there is a meeting going on, and then there are X number of people on this meeting, and the number of people in the meeting is fixed, right? And it is the state on my computer. It is likely to be the state on all of your computers. At any moment when we freeze the state of this application, the state would be common across all of our computers. That is the number of participants at maybe what is the time now? Okay, it is 10:23 p.m. for example in India. So at 10:23 p.m., the state of the application is like this. There are X number of participants. There are 14 participants, right? There is a firefly note taker, and there is this particular slide, architecture slide, that is being exhibited. So this defines the current state of this application. And the state of an application is always, you have to think of it as a defined at a snapshot, right? At a moment, what that application looks like. So the state of Ethereum, Ethereum is called as a global state machine because at any point in time, at any snapshot, what you see on Ethereum is what everyone sees on Ethereum. So it's a global state machine, right? And we will talk a little, I think when it comes to EVM, there will also be more conversations around state changes. What does that mean? Let's say someone leaves this meeting, right? The state of this application has changed. The number of participants has become from 14 to 13, right? Similar to that, when there are transactions that happen on Ethereum and there are blocks that are created on the blockchain, the state of the blockchain changes, right? There are some accounts that have transferred funds. So those wallets, their balance would have reduced. Some wallets balance would have increased. If you bought an NFT, initially your wallet was empty, but now you have an NFT. And then if you paid for it, then your balance of the wallet was decreased, right? So these are all called state changes. And when you take a snapshot of your wallet at any point in time, That's the state of your wallet according to the state of the blockchain. So whatever is the state of your wallet will be the same as the state of your blockchain. And Ethereum is called as a global state machine because it is a machine that will always have a global state. That is, what you see is what everyone sees. So that's called a global state machine. So anytime you're thinking about state, right, that state is nothing but data, that is information. And in this case, when you're thinking about state in Ethereum, you have to think about information that is surrounding Ethereum. So transactions happening on Ethereum, applications interacting with Ethereum, transfers happening on Ethereum, NFTs being bought and sold on Ethereum, all of these are state changes on Ethereum. And EVM is the one that is executing those state changes. So when you say that you want to buy an NFT, who's doing that for you? Who's changing that state for you? Who's making sure that the balance from your wallet is deducted and the balance in that NFT contract is increased? Who's making sure that NFT is being transferred from one address to another address? All of this execution is being done by the Ethereum virtual machine. So that's why it is the heart of Ethereum and it is part of the execution layer. So execution layer will do the execution for you. Whatever you want to do with the blockchain, that execution will be done by the execution layer. So now Reet is explaining what are the different components of the execution layer and how does it work. Is that clear? Are there any questions as of now on EVM and state?
Not for me, that's clear.
Okay, perfect. Okay, Reet, please continue.
Yeah, so before I move on to the transaction part, I would like to take 2 minutes and talk about accounts that are there on Ethereum. So Ethereum has two accounts. So when I talk about accounts, like I would like to simplify it to the point, real world accounts, like we have bank accounts, right? So similarly, Ethereum has two accounts, that is externally owned accounts called EOAs, and the other one is contract accounts. So when I'm talking about the transactions can only be initiated by EOS. Now, what is EOS? If you have interacted on MetaMask or any such wallet, you would have received your private key. So in simple terms, if you have a private key, that means you are interacting or you are using an EOA, externally owned accounts. The contract account is basically the smart contract. So we'll talk about smart contracts and how to write smart contracts also in like the later lectures. But essentially, contract account is basically if you write and deploy a new smart contract, the address of it would be the contract account. So that's coming to transactions. Transactions are basically piece of instructions, and who can initiate this piece of instruction? EOS, externally owned accounts. So basically, how this state like how this state transition is supposed to happen, and if it is correct based on the rules defined by the network. So transaction can only happen if you can cover the certain gas fee, or if you want to do a transaction of 1 ETH, you should have that money in your wallet. So these kind of very basic certain rules are there on the network. So if a transaction is successful, then only the state of the network or the state of the blockchain Ethereum will be updated. So unlike Bitcoin, so like Ethereum follows an account model. We saw I told you about two accounts, EOAs and contracts account, but Bitcoin operates on a separate different level on UTXO model. So that's majorly the difference, and that is why the state is changing, and that is how we come to the conclusion that Ethereum has a single global state, and we already saw how that comes. So all of these transactions come from a meme pool, that is a pool of all the transactions coming to the network. So a simple way to understand it would be like to go on etherscan.io website and see like whatever transactions happened on that website. You can actually see all of them happening, and those are actually open to all of us here. So, and with each transaction successfully happening on the blockchain, the state is getting changed, and we are getting the data on the EVM. So that is how it works. Now let's come to the P2P here. So P2P is basically the communication interface with the other nodes or the other clients in the network. So this all is basically Like this is how we communicate, this is how the transaction is communicated. So if you are using Ethereum wallet or any dApp also, be it MetaMask or any other dApp, you are talking to the execution layer using some JSON RPC API. So using some RPC API. So basically, if I want to, API has many different methods. We might know get method, post method. So in this JSON RPC method, you can read data also and you can write data also. So reading the data from the blockchain doesn't cost anything, but writing the data will require some gas fees and stuff like that. So this is how the execution layer is, and the user is sitting here. So if you're using a wallet or a dApp, you're connected to directly to the execution layer and not to the consensus layer. But the execution layer itself is connected to the consensus layer using the engine API. So engine API is something that is implemented by the client that talks to the consensus layer. So how does the execution layer will know what is correct or what all of the other nodes agree on? We need to all of us we all the other nodes also need to agree on what is the current state of Ethereum. So if a transaction is happening, all of the other nodes should be aware that okay, yes, this transaction happened, the state of the Ethereum has changed. So that happens because of the fork choice here. The fork choice is the one that is responsible to dictates the current state of Ethereum, which is of course managed by the consensus algorithm of Ethereum, the LMD host here. So these are basically communicating with each other and deciding the state of the Ethereum, and then that is communicated from an engine API to the client, and that comes to the execution layer. So this together with its own P2P network. So you see that a consensus layer also has a P2P here, and the execution layer also has a P2P. We need to understand that both of these P2P are completely separate, and other parts like consensus layer also has blobs and random. So these are basically to replace the randomness of the layer, consensus layer. So consensus layer will also have its own API here that is called the beacon APIs to learn about the consensus state. Like this API is used to learn about the consensus state, things like how many validators are there. The validator will use its key to sign in, I believe, like to understand if the block is correct or not. And as I said, both of these P2P networks are completely different. I would like to just show the next slide also, because this is a very simple explanation of what we just saw in the past slide. So this is the validator, and this is how the user is interacting here. We have the execution layer, and this is all of this is a client, and these are connected by the engine API, and both have their own separate P2P networks. Again, do you want to take some questions here if we have any?
Sure. If anyone has any questions, I'm here.
Hey, the consensus layer and the beacon node layer are the same things or different?
Let's see. The okay, here we have okay, the engine API between the consensus layer and the execution layer. And this is in the next one, I think the consensus layer is the beacon node. Okay,
Okay, so they are the same things, right?
this is a good question, and I will show. Okay, I'm excited to show beacon. Maybe let's see this with the diagram. Okay, nice. Ethereum documentation is just so nice. Lot of words. Okay. Sorry. Don't look at my office Slack. Okay. Beacon chain, why they call it beacon, I think it's interesting because now they moved from proof of stake to proof of work to proof of stake. So they call that as the beacon chain. What does the current consensus? So okay, you saw the execution layer, right? Where the execution happens. Like you ask that, hey, I want to transfer X amount of money, and EVM takes that command, it executes it, right? But sometimes your transaction fails. Why? Because maybe you don't have enough gas, or maybe your transaction doesn't get picked up immediately. It takes a while for your transaction to get picked up, right? How does your who decides in which block should your transactions go, right? This is a there is another place that I wanted to show, which is Etherscan. If you're not familiar with Etherscan, it basically shows you what Ethereum looks like today, right? So Ethereum consists of blocks, which is every blockchain. Similar to all blockchains, Ethereum also has blocks. And all of these blocks, you look at these numbers, these are block numbers. Each of these blocks will have a bunch of transactions, right? So your transaction is also going to be picked up by someone, right? And it is going to be processed, and the transaction is going to be added onto the blockchain, right? So this process of picking up the transaction and adding it to a particular block. So you see that this particular block number 20771701 has a lot of different transactions. You can see that someone has transferred something to Seaport, someone has transferred 0.21 ETH, or a lot of different things happening, right? There is USDT, someone has transferred from Mercury, and then some hot wallet, or something is happening, right? A lot of different things are happening here. Guapi.eth interacted with Uniswap contract for 5 ETH. Okay, very rich. Okay, so you see all of these different transactions, right? One of these transactions could potentially be yours.
Jan,
So
we can't see your screen.
you can't.
Yeah, I thought it was just my phone. Maybe.
Oh, you see it now?
Yeah, now it is clear.
Let me swap. Okay. So one of these transactions could be yours. Okay, so earlier I was showing you this block. I was showing you this Etherscan main page. This is how I came into it. Then I went into one of the blocks and I just looked at the different transactions. So there are 167 transactions and 92 contract internal transactions. We'll talk about these later. It's just some other different types of transactions, right? So when you click on transactions, you see a lot of different transactions. The one, if you want to know that rich person, it was this Guapi.eth, right? They invested in Uniswap and did something for 5 ETH. Okay, interesting. But you see, each of these are a transaction, and one of these could be your transactions, right? And your transactions get picked up and put onto one particular block. So in this case, all of these transactions have been put into 20771701. Now, this action that you perform of taking a transaction and putting into a block, this happens through a set of rules, right? Because you can't just add any and every transaction, right? So this set of rules that allows that checks whether a particular transaction is correct or not. Because let's say Guapo.eth spent 5 ETH on a Uniswap transaction. But who checks whether Guapo.eth actually has 5 ETH or not? What if they only have 2 ETH? Then their transaction should ideally be rejected, right? It shouldn't be accepted. So there is a set of rules according to which the transaction will get accepted, right? And this set of rules is validated by a bunch of people called validators, right? I'm trying to show there's like a image for this, and these validators are the ones that form your consensus layer, right? So if you think about everything is so complex, I hate it. Okay, let's see. Nice diagram. I don't know, is this nice? Fairly okay. Okay. So if you see validators are the ones who will actually check whether your transaction is correct or not, right? So these are a lot of different transactions happening. The validator will validate that particular transaction, whether that transaction is correct or not. And then they will say, yes, this transaction is correct. Let's put it into the blockchain. Now, how many validators should actually check that transaction? What are the set of rules that they should follow? How can one become a validator? A lot of this goes into an algorithm or a set of rules, and this algorithm is called as a consensus protocol. So you see, proof of work is a consensus protocol. What does proof of work tell you? That a particular miner, right? We used to call them miners. A miner has to run a mathematical equation, and they have to get us an answer. If they get that exact answer that the network is looking for, they can decide which transaction should go on this particular block. Similarly, now in proof of stake, a validator has to stake or lock in 32 ETH into the ecosystem, into the blockchain, and they can become a validator. As a validator, what will they do? There'll be a lot of transactions coming on the Ethereum blockchain. They will pick up the transactions and they will check whether those transactions are correct or not according to a set of rules or a program that is given to them. Now this validator runs this set of rules, and then they add that particular, if the transaction is correct, they will add that particular transaction into a block, and they get to add the next block to the blockchain. That's how blockchains keep getting, that's how more and more blocks keep getting added to the blockchain. So now in proof of stake, in the newer version, why they call it the beacon chain network, right? Because they are trying to implement something called as a sharding, right? Let me try to show you that as well. Ethereum image. So sharding is like, instead of one group of people doing all of the operations, there'll be different smaller group of people that will be doing all of these operations. For example, right now when a transaction comes, you have one group which is called Ethereum validators, right? All of these validators, depending on the rules of the Ethereum, will take these transactions that are coming. They will try to validate it. I mean, set of validators, whether it's 1/3, 2/3, how many validators are required to validate, that is already set as a rule in the blockchain. These validators will take these transactions, they will run it, and they will. So every transaction, if you think about it, in a way, is processed sequentially, right? In a way, not exactly, because multiple people are validating different sets of transactions. But if you think about it, it is coming one after the other. But when we have many validators like this, right? When we have multiple small groups of people doing these transactions in parallel, right? That time your network efficiency increases, right? Right now, Ethereum is not that scalable. That's why you see a lot of layer 2 solutions. But to make it scalable, Vitalik, I mean, the next step in the Ethereum roadmap is sharding, right? So they are working towards it. And there'll be different group of validators who will be doing this validation parallelly at the same time. And there will be one chain called the beacon chain that will take all of this and that will monitor the different shards. So that is why right now the consensus engine is called as the beacon chain. But consensus means, do we all agree that this is the rule to add the next block to the blockchain? That's why it is called as consensus mechanism. And that layer that is called the consensus layer is trying to do exactly the same, that it is trying to follow a set of rules that will make sure that a block is added to the, how should a block be added to the blockchain? Those particular rules are given over there. Yeah. Those particular rules are there, and that consensus layer will follow those rules and add the blocks to the blockchain. Uh, okay, yeah, sorry, I hijacked a bit of time, but I hope it is okay now. I have to stop sharing my screen immediately. No. How do I stop? Okay, sorry. Are there any questions on a consensus layer? Oh,
I have a question on fork choice and LMD ghosts. I didn't understand how that works.
what is this LMD ghost? Oh my God,
Yeah,
I have no idea what
yeah.
LMD ghost. Reet, if you have an answer, go ahead. Otherwise, I'll have to check.
Yeah. So I'm just fork choice is basically the one that is dictating the current state of the Ethereum, which as Gyan explained now, like how do we come to a consensus to what is the current state using consensus mechanism, which currently we are using proof of stake. So fork choice is just the one, like you just need to understand that all of this is basically nothing, just proof of stake. So fork choice is the one dictating, and how does fork choice come to know? It is managed by a consensus algorithm that is inside this LMD ghost, which is currently proof of stake.
Yeah, so if you can think about it as like there'll be lot of people who'll be simultaneously creating blocks, right? So how do you decide? So if you think about it, this is a block that just got formed, right? There'll be different validators who are working on creating new blocks. So there'll be a validator who may see the state of the Ethereum as, let's say this is the recent block. They may see the state of the Ethereum here because they have updated their node only until here. Some validator may see the state of the Ethereum here. Some validator may see the state of the Ethereum here. Some validator may see the state of the Ethereum here. So the ideal state of the Ethereum global state is here. So you actually should add the block here, just after the global state. But different people see different things because it is a distributed system, right? So as in it could be because of time lag also, right? That your computer takes a while to get all of the data, but maybe my computer is faster, and I reach here before you reach here because of the processing power, right? And I add the block here, but maybe you add the block here. So how do we choose which blockchain should it be? Should it be this one where you have added the block, or should it be this one, right? Ideally this is the global state. So this particular LMD ghost protocol will decide the fork choice. How should the chain be forked to continue, right? So in that case, when some other validator adds a block which is not in the main fork, right? That fork will not be chosen. This fork is discarded and this fork is continued. Like that, you will see a lot of instances because people are always competing to add new blocks. So, which block gets added first onto the global state, right? That is the fork choice. That, and then maybe it's not just about time, it's also about some other factor. Whether this block has all of the transactions that are correct transactions. Maybe this block has included one or two false transactions. In that case, it will not be accepted. So this LMD Ghost protocol will decide which chain to continue building on top of. So that will be the fork choice.
Great. Yeah, that's clear. Thank you.
Okay, so the previous slide that Reed showed was also similar to that, where you have the consensus and they're calling that as the beacon node because of the sharding part, where you have one node which is the beacon node, and then you have the execution engine, and the engine API is the one that you use to interact between the beacon node and the execution engine.
So if we have understood this far, like 80% of the work that needed to be done in today's lecture is like done. Like today's agenda was just to understand the architecture of Ethereum, which is complete. Now it is just like very small topics and very easy ones also. So this is just a nodes, like if we know a little bit about networking or stuff like that, this is how, like the first way, like the blue nodes is basically how a network works in a normal way. So this is how all of our computers or the internet is connected. So this is like a central server and you are connected to a central server. I am connected to the same central server, and maybe Fabiola is connected to the same central server. Gyan is also connected to the same central server. This is how the regular internet works. So you get the gist now. But Ethereum here is, if you see the red nodes here, each node is connected to all of the other nodes in the system. So that is basically how decentralization in general also works, and that is how Ethereum or any other blockchain will work. So just to understand the difference, it's a very simple slide here. Coming to the implementation part, the EL means execution layer here. So there are a lot of implementations done on the execution layer side. Uh, like the pretty famous or the pretty one that I mostly use is Ethereum JS, as it is on TypeScript. And when I'm interacting with Web3 or decentralized front ends, I'll most probably use this one. But there are other implementations implemented in different languages. So Geth is implemented in Go, Nethermind has their own in C Sharp, and there is one in Java also. And there are basically other, like one in Rust, one in C++, another one in Go, Aragon also. So if you want to explore all of these stuff, you can. So Silkworm is also there in C++ also. So I'll show some implementations that is done on the consensus layer, and also this is also like we have Prism in Go, Lighthouse in Rust, Teku in Java, Nimbus in Nim, and Lodestar in TypeScript. So these using
Sorry to interrupt. Can you tell also about what these implementations are doing? Like, what are they? What are they doing?
Yeah, so let's just talk about the simplest one, Ethereum JS. So if I'm like if I want to create a front end on React, and if I want the user to connect wallet in it, I will use Ethereum JS. Now, if I want to fetch the balance of the user, there are simple methods to do that. So ETH get balance is the one that we use on the client end to fetch the balance of the wallet. And there are a lot of so these methods that I'm talking are just read methods. So we are just fetching something, not write ones. So there are also read and write methods in each and every implementation here on clients end also. Since I'm talking about the execution layer here, and the client is interacting with the execution layer, so that is where it all comes in. Consensus layer, I'm not really sure. Gyan, do you want to take this up?
Yeah, so consensus layer is basically providing, so like validators, right? Validators will run something on their computer, which is the set of rules, in order to fulfill the rules of the consensus layer. So these are the clients that are provided to the validators so that they can run these clients on their system, and they can perform the validation or the operations of the consensus layer. So with execution layer, which was the previous slide, right? We can't really do the execution layer, but what we can do is we can interact with the execution layer to get the state of the blockchain, right? Because EVM does the job of the execution layer, but we can't do it. But we can use these clients to interact with the execution layer to get the information of the current state of Ethereum, right? So like Reet mentioned, you can get the balance, you can connect wallet, and you can do all sorts of things associated with the blockchain. With the consensus layer, you can actually become a validator, right? And even if you don't want to become a validator, when you run any of these clients, you can actually get the state of the blockchain, right? So why is blockchain called as a distributed system? Sorry, it works on the principle of distributed system. So what is distributed? This information of the global state is distributed. That is, this information of the Ethereum state machine is available across the globe. How is that available across the globe? Different people sitting in different parts of the world can run these clients on their computer and get the information of Ethereum. They can decide to become peers to broadcast this information to their peers. So let's say I am running an Ethereum client on my computer. You can actually request for the latest information from me. Now we have a lot of different things like Etherscan and all of that, where you can see the latest information. But you can also just ask me as a peer that, hey, what is the recent global state of Ethereum, right? And I can give that to you if I'm running these clients. But let's say I have the money to become a validator, which at the moment I don't. But let's say I have the money to, I have 32 ETH, I can lock 32 ETH into the Ethereum blockchain, and I want to become a validator. Then I can become a validator, I can run one of these clients, and I can run that consensus mechanism, which is nothing but a program that runs on these clients. So these are the clients that you use to interact with the consensus layer, as in to run the consensus mechanism yourself.
Let's move to the testing part. So why are we discussing testing here? You must have heard this term called auditing. So Ethereum or the smart contract also has a property of being immutable. So once the smart contract is deployed, you cannot change the code. Nothing can be changed once it is deployed. So that is why a lot of auditing needs to be done, or testing needs to be done in the smart contract, so that the code is secure, and we can also maintain the very simple design principles of Ethereum as well. So I have mentioned some repos here. So these are some client testing repos also. So some of the like if you see here on the fourth part, there is Hive testing. It is end-to-end harness tool. It can spin the network with different clients and run them together with a different test. Like this is not something important or you need to explore right after this session, because we have a separate class on testing. But to understand why we are doing testing and why testing is important in general in every software as well. But in blockchain, especially, smart contract auditing is a separate field and is a very important one because of the immutability nature of the smart contracts. But you can check all of these repo in case there need to be. These are some other tests also. So what if we deploy a huge amount of validators? Does the blockchain survive? There is a flaw in the client process. Will our application run? So all of these benchmark testing or the performance of the application testing are covered in this here. So other tests, like we have unit testing in the normal software world also. So these are all some of the other sort of testing that is done in a blockchain here. This is all about testing. Before wrapping testing up, do you have any questions, or is it too simple?
No questions.
Perfect. Now we come to the last topic of today's lecture, which is blockchain trilemma. So any blockchain, like talking about Ethereum here, but any blockchain has three pillars to it, that is scalability, security, and decentralization. So in an ideal world, we want to be at a maximum capacity of all these three pillars. We want to be the most secure, most decentralized, and the most scalable blockchain in the world. But the problem is why it is called a trilemma. If you want to achieve one, you sort of compromise on the other a little. So I believe like all of the blockchain has one thing more than the other two things, which in case in the case of Ethereum initially focused on decentralization. But of course, it does not mean that it is not secure and not scalable. It is to some extent, but the main pillar of the focus was decentralization. So decentralization is nothing but the ensuring that the network is controlled by everyone and everyone has a say in what actually happens here. We saw in the node topology that how everyone has a say and everyone is connected to every other node. So that is how the decentralization is achieved. And in terms of scalability, it is handling a large number of transactions quickly, but I believe it is associated somehow with gas fees also. If we are paying huge amount of gas fees, then it is fair to say that right now the blockchain is not as scalable as we would want it to be. So, like as you see in the pillar, like typical high TPS chains and multi-chain ecosystems, and here comes the traditional chains like Bitcoin and Ethereum. They are mostly lying here in the space of decentralization and security. Coming to the scalability part, we discussed the scalability part, but coming to the security part, we just need to make sure that the network is protected from ransomware attacks or attacks happening on blockchain these days. So this is the two pillar. Now, why we needed L2s? It is because Ethereum could not be scaled at after a point. One of the main reasons of shifting from proof of work to proof of stake was also that the gas fees was very high, and the proof of work consensus mechanism was also very energy consuming. So basically, to burn less trees, we just barely needed to shift to proof of stake because Ethereum has a lot of transactions happening on a daily basis. So to handle those, we needed a lot of scalability. So it is a little bit more scalable after we shifted to proof of stake, but it is still not at its place. So there are a lot of L2s coming in which are offering very cheaper transactions, basically being more scalable, but somehow they might be a little compromised or either security or decentralization. So that is how we understand the trilemma, and we understand the whole blockchain ecosystem as well using this. Any questions here?
Amazing. Any
Not for me.
questions?
Okay.
Yeah, so I think this is mostly it for today. We have covered most of it. In the next lecture, we'll be focusing more on the execution layer. So now that we have a understanding of the architecture, we'll go layer by layer and then understand what is happening everywhere.
Okay, this is amazing. Do we have any questions just overall? Okay. Okay. If you also have any questions later on, don't hesitate to put it in the Telegram group. And I'll also share the Discord group for the Women in Ethereum Protocol Discord group. So you can join that as well and maybe ask questions there in case you're interested. You will definitely find answers there as well. But we will be happy to help you. If you have questions on the feel free to post it on the Telegram group as well. And you should start working on your EIPs now, because you will have a couple of weeks to research, look at different EIPs, start from something easy and then progress to something a bit more complicated. And then if you feel like there are some subjects that you want to go deeper into and want some sessions on that, I can arrange those as extra sessions as well. Like maybe client side, how do Ethereum clients work? Maybe someone from the node and client team, we can invite and share someone from Nethermind perhaps to talk about how clients work. Or you feel like you need a basic refresher as well. I have some videos that of lectures that I did in the past, so I can share that just for reference. And then also I suggest to go through the week one Wikipedia page. So that will help you build up on for week two, because there might be some information that could be added there that could be helpful as well. And yeah, that's pretty much it. Thank you so much, Reet, for a great session. And I look forward to seeing you all on Telegram, asking some questions. If you're starting to prep for your EIP presentations as well, just you can feel free to share. Like you can also share in the group, hey, this is the EIP that I'm researching. Do you want to join me? Find a buddy, talk about different EIPs, cool stuff. Always happy to encourage more interaction in the group. And if you have any questions, we try to get them answered as well. And I will post the recording on the